challenge, but we had some problems, and I think we spent too much time solving edge conditions instead of just focusing on just the specification that was in the requirements in the task. So I'm making small changes now, again, to be back on track and focus on just what I needed and not more. So return null. So the issue that I had was, what if two wires overlap like this? So this is wire 1. And what if on wire 1 we have another wire, which is this? Are those wires overlapping? What are their cross sections? And that's the thing that bothered me, since I went for a geometric intersection, and I cannot really do that if surfaces intersect instead of just points. And the approach to find that would be completely different. So yeah. Tangles, distinct, equality comparer. Yes, this is still enumerable of point. Good, and we're back on track. Find closest, this is quite bullshit. This is not what closest is. For tangle some points, I still don't have a way to calculate Manhattan distance. So I need that. So basically, let's run the test now. In theory, my tests should pass, all except one. And yeah, this one fails. And I would like to fix them. And the fix to them lies by removing this silly case that I have here. But I still want this case. So this is overlapping points on a corner, and this is overlapping points with a sticking wire end. So those are the two test cases that I have for finding the tangles. So in this case, in both cases, it's a single tangle that's found. Yeah, now it succeeds. And now I need Manhattan distance. Pairs of lines with intersecting, so lines search should return expected point. Yes. Closest intersection point. It's a distance. And even, wait. Don't I have tests that read from file? I'm confused. Here, panel tests. So I have line test, cross wire test, but my panel tests are still not being run. Why are they not discovered? They're probably failing, which is a good thing. They should be failing. So I need to calculate Manhattan distance. And I'm doing this completely wrong. So let's implement that. Manhattan distance of a point equals to a sum of its coordinates, but here's a catch. And I'll show you the catch. If I go to the point, so I want to write a test to a point, so I'll go to a point tests, and I'll say theory, member data, name of some random points, negative mixed points, input. So let's create that. Mixed points input. So we'll have a bunch of points. -1 and 1. And the output should be 2, the distance. Minus and then 0, 0, the output should be 0. And positive. And positive. 1, 0. The output should be 1. Or more like this, 2. Good. So we have our input and now the test. Manhattan distance on point as expected. So we take in a point and we take in expected int expected distance. So we say point dot Manhattan distance assert point Manhattan distance should be expected distance. Let's add that property. It's a get-only property, which does basically something like math apps x plus math apps y. That's Manhattan distance. So that's it. Let's run the test. Perfect, it works. Now let's continue with one thing. If I go to panel, we have a bunch of stuff that's failing. And the part that fails in particular, or was it wire? Panel or wire? Entangler, that's the one. So I should have ordered the tangles by t Manhattan distance, and in ascending or descending order. Source elements in ascending order. So first or default is the tangle that I want. Tangles dot first or default is the one that I want. Let's try again. It fails. Expected distance to be but found 109. Let's open this thingy and see. This is not with an example, sadly. Okay, let's use this input. This is quite nice input. So what's the distance? 6. So 6. 1, 2, 3, 4. Sorry, 1, 2, 3. Yeah, 6, good. Let's add one more test in wire tests. Point tests, panel tests, line tests, crossed wire tests, panel tests. Distance is 6. I expect 6. I go to input, paste it. I say distance is 6. And let's work with it. One is this. And the other one is this. Yep. This. Okay. So panel tests, let's run. Okay, that one succeeded. That's a good thing. Hello, Nicolo. Nice to see you again. I'm wondering, what am I doing wrong in this case? Why are those two tests failing? I took the trivial case, the example from what they had, this one, and it seems to give the right answer. Distance equals 6. So basically, this is being solved. It finds the closest one, like this, and finds the distance to this is 6. But it doesn't work with other things, and why is that? Good evening, Krolov. Yep, this one is tough. I can't figure out where I made a mistake. Let's take good old paint and sketch some lines. Because why not? Let's see what we're supposed to get. So this one, this is our origin point. Let's take different colors. So I go there, then I go roughly there, then I go roughly there, then I go right down 63, roughly this much, 33 to the right, this little, up 87, (62) to the left. Uh, 20 down. Probably intersecting. I'll mark it an X. (62) down. 20 down. Definitely intersecting. Wait. So it's the bad case. It's the severe case of overlapping wires. So they can be overlapping, and I need to modify my solution a bit. It's not a bad thing, but I didn't know that it can overlap like this. So let's make some changes then. And let's include one more test, which will make my solution fail, but which will let me fix it. And thus I will be closer to the actual solution. Tangled wires, yeah. This one is the one that I want. Overlapping multiple points. So what if we have two wires that are identical? That means that we have 3 points that are overlapping. Right 1 means 1, 0. Up 1 means 1, 1. Left 1 means 0, 1. And that's the overlapping points. So when I build a wire out of the literals, I need to build such points. I need to plot it point by point. This is the approach that I discarded initially because I thought that it's a waste of memory, but now I think I see that there is a case where wires can actually overlap on top of one another. And my current case is not really suitable to solve it. So, we have a point, and now instead of being happy with this point, we need to plot more points. So we know the direction it goes, and we know, right, so with this, what we have here, we have dots of corners of a line, of a wire, but not the dots in between that marks its path. And now we need to add that. So, so this is our path. I will create a private method. Private. So given 2 points, I will plot a range of them. I will plot a range of them, yeah. Path corners. Plotted returns, plotted points in between wire corners. So private enumerable point plot between 2 points. Maybe it's better suited for a public method on a level of a point, so I can test it. I would like to test it. I'm not confident that I can implement it well immediately. So we take 2 points, and var plot is new enumerable point. Whoa, what am I saying? List. And we return it. Plot. Points, I guess, whatever, points. I will implement it soon. Now let's go ahead and add a test for it. Theory points plot. I guess I can. What do I take? I want to take 2 points, and I want to take a list of points to see if I plotted the correct one in between. So points plot input. I hope that you will succeed, Roloff. You do have potential for sure, and if you don't give up, you will reach it eventually. Points plot input public. I'll just copy it. And points plot input. It's definitely not helping to me that every day of this week I had only 4.5 hours of sleep, 4.5 to 5.5, and work early, go to sleep late, since I would go to sleep at 1:30 a.m. So it definitely doesn't contribute to my efficiency at solving those. Okay. What do I want? I want 2 points. So if I take 2 points like this, and another one. 2 points like this. So I expect that it will plot something in the middle. So it will include this point, it will include that point, but it will also include the point in between. So this point, that point, and point in between. Next. Same if it is, wait a minute, why? Oh, I should have put this list of object array, new object array. List of object array. Right. Right. Quite confused. So that's one. And this is second one. Also, object array. Good. So, what do? We take now a vertical point, a vertical line, and we check if a vertical line got it correctly. So 0, 0, 0, then 1, 0, and then 2, 0. And so plot in between 2 points should include both points and more, as expected, and more. So I say point plot this will be a static method. Point plot point 1, point 2, and var plot should be equivalent to expected plot. So 0.1, 0.2, and we have expected plot. Good. So let's run the test and see what happens. It failed, and it was supposed to be failing because I return always empty collection. So good, it fails. So let's go back and let's do what we're supposed to be doing. So we need to determine orientation between 2 points. So I will build a line. A line. That's actually a line method. So I will move it to a line thing. Yeah, that's definitely a line method. Line. Wait, what did I just do? I totally forgot what I did. Point plot. Right, so I want to go to line. That's a concept of a line. Public static, it's not static anymore. Public enumerable plot takes no input because it has in itself those 2 points already. So var points, newest point, and I say, and this is fine. Now I want to move the test from point tests to where it belongs. Good. So I want to move it to line tests. So I want to say, given 2 points, I create a new line. And then I plot new points from that line. So all points in between. And I expect the plot to be the expected plot. Gets all points in between 2 points. Awesome. Run the test, see if it builds, and implement the test. I think so, it ran, right? I don't know. I think I need to build, I don't know, I didn't notice what I ran, to be honest. Build succeeded, run. Line tests, yeah, good. So I go back to plot and I implement this method. So if orientation, so line has orientation, and if line orientation is horizontal, if it's a horizontal line, then it means I need to plot axis. So it's like this. This is the line. and these are our ends, so I need to plot x's. Else if orientation is vertical, that means I plot y. So something like this. So let's implement that. I need to say I need to do a for loop for var x equals not 0 but the first point. Right, so I need to first pick the bigger point. So if start dot x is more than end dot x, then my start x is the x that I start with is the smaller one. It's the end x. Else it's the start x. And this is because we need for it for the loop. X is less than the other x. So I'm probably better off to just having if statement. So start x is this, and I also need end x. And my end x would be my start x. And here my end x would be my end x. Good. So here I say start x, x plus plus, x is less than end x. Y is plus plus to bool. Oh my god, I'm stupid. X plus plus. And here I do, I start from the point that I am ahead because I already had the point that I need to add. And I end a point before because I already have the ends. I already have those 2 points. Though does it matter? It does matter. So I start with a list of already including points. So yeah, I start with an already including points. So I start with start and end already. Actually, just start. So that's my start. And then I keep adding new points. So y doesn't matter in this case. Start y. It doesn't matter. And I take y. And as I do so, I add those points to the points list. And when I'm done, I also add the endpoint, but not in this tiny loop, but here. Points, add, end. And now I need to plot y. So x is constant. So I can say int x is start x. And again, I do the same. I really need to refactor it, but at the moment I don't know. I don't know what to do. It's a bit silly. But it's a challenge. It's a good refactoring experience. So do the same with y's. And actually just replace all the x's with y's. X with y. And non-capital X with non-capital Y. If and y and y start y and y start y and y. What the fuck? Y and y. Y, x and y, the same. Yes, that should be it. Good. We add points. We return points. Perfect. Let's run. Should work. Doesn't. What's the error? Manhattan distance. Well, it's the sum, so whatever. Expected plot to contain collection with 3 items, but 2 items were there. 1 item less. Yeah. Why? Plot. Points. Start. If start is more than end, then start starts at end and ends at start, because that's the bigger one. That's it. Start and end are defined. We start at start y plus 1. We end at and y minus 1. Probably I overdid that thing. That's where we start. Because it's less. This one starts, so it's inclusive. This one is less, so it's exclusive. And that's why we didn't get the bit that we wanted. Good, and now the test method. My input is malfunctioned. So I take in a point. Two points. An array. The test method expected, but one parameter was provided. Oh, I see. Let's run again. Oh, okay. It's actually a bug in the test explorer because I just completed the test, but the failed test still shows up as incomplete. So I'll just rebuild. I had so many issues with tests and so many more issues with people who try to run tests. I mean, people really struggle setting tests up, and this is that's one of the factors why they don't write tests, because sometimes they just don't work for random reasons. All right. So the X part is somehow messy. Let's figure it out. X and X. So if start is more than end, so it starts at end and ends at start, else it starts where it should. And this is X, this is Y. And I messed up because Manhattan distance, because it's Y is constant, so the line is horizontal. I'm confused. Wait. I don't take it away. That's what I should have done. Okay. Silly me. Okay, good. So this bit is done. We now have a way of plotting points. And if we have a way of plotting points, maybe, So we have a way of plotting points. And now let's implement of having a list of all the points on a wire. So crossed wire test. Wire parse. We have points. wait. Okay, so if I go to a wire, we have that it gets all points. I'll call it get corners. Find corners. Plot corners. More like get corners is okay, I guess. And we have corners. And from those corners, how do we have the corners? List. Perfect. We say for var I is 0, I is less than path corners dot count, path I plus plus, and we say that we want to take and -1. Take 2 points. Actually create a line. Well, it's a waste of memory if I create a line just to call its method. So let's refactor one bit. Line plot public static I enumerable point plot. So it takes 2 points. And here I replace start and end. And here I'll say that all the start is start. And all the end is end. Fuck, I need orientation. Okay, it was fine as it was. I'll create a new line. I need to figure out the refactoring later. So if I go to wire, I say line is new line which takes in point. It takes in point. So new line with path corners at I and path corners at I plus 1. Done. And I say line plot var points and var full plot of point, and then I say line plot. Add range. Good. And we return plotted points of distinct. I point new point equality comparer. To list. Okay. And I need to see if wire is as expected. So I need to check wire tests. So I need to parse the wire. Wire tests. Single wire literals expectation. Good, and the last bit that will cover this logic. Oh, sure, I can do this in the same test, actually. R2, U2, L2, D2 will return each different points in between. So if I do R2, then it goes 1 and then it goes 2. If I do up 2, then it will go 1 and then it will go 2. If I go left 2, then it will go 1 and then it will go 0. And then go 0. And if I finally go D2, it will go x0, y1. Literally what I said I wrote. Oh my god. I'm sorry guys for so many fails. I've been really tired recently. Good. So if I go back to my wire tests and run this again, 5 of them failed. Wow. But found an empty collection. Empty collection. Right, for a single point, it should return a single point. So well, a single point is not a wire, to be honest. So that's silly. But I'll change it. For now it will do. So if path corners count is 1, then return path corners immediately. Because I don't want the mistake of the tests. So if I run again, the test will be fixed. And that's TDD for you. You hack solution around just to make tests pass. Expected path with collection with 8 elements, but contains 1 items less. So what am I missing? With 8 items. Two, 3, 4. What am I saying? 2, 0, 2, 1. Huh? 2, 0, 2, 1, 2, 2. 0, 1, 2, 2. Yes. 1, 2. Okay, this is good. 1, 2. Wait, what? Oh, I start from here. 1 and 0. I think my test is failing. I mean, my test is failing because the input is bad. One, 0, 2, 0, 2, 1, 2, 2. 1, 0, 2, 0, 2. It goes up. Yeah, it goes up. 2, 1, 2, 2. It goes left. 1, 2, 0, 2. 1, 2, 0, 2. It goes down. 0, 1, 0, 0. 4 corners, 1 point each in between. That's what it should have been. And I'm missing which point? 2, 0. 2, 0, 2, 1. 2, 0, 2, 1. 2, 2. 2, 0, 2, 1, 2, 2. 1, 2. 0, 2. There is no 0, 2. Okay. probably this -1 is messing things up. And the answer is shouldn't be. Oh well. Let's debug and fix it. So our first plot easier to debug, so I'll split this. Let's build, and please refresh my tests. Run this, fail, debug the failing one. Plot 2 points, plot 2 points, plot 2 points, and as expected, the last one for some reason plots to 1. Why? It doesn't get hit. Back. Interesting. It doesn't get hit. So if my count is so I first plot. Oh, I see. I know what I missed. I need to start plotting from the origin point. So yeah. So plot from origin point. So var line from origin is new line from new point 0, 0 to first point. And I say or include origin in the wire setup. Okay. So plotted points, add line from origin plot. Add range, I mean. If I run this now, it should succeed. And my final test is the panel test where I work with intersecting wires, and I don't do the intersection here yet, but I will. So wait, wire test, sorry, not panel, but wire test first. So untangler, sorry, the entangler is the one that does that. Find closest angle, calculate shortest distance. Closest Manhattan. And in this one, find tangles. Yes, but it will be absolutely different now. It will say wire 1 dot path intersect wire 2 path, and I do so using the point equality comparer. Return tangles. Let's see. Panel, this one is the one that I should have tested. I like that it doesn't work for trivial case. At least I can have easy solution. Not easy solution, but easy check. For tangles. So, what? Okay. Interesting. What's wrong then? Why is this not working? Seems to be just about right. Or did I mess up implementing intersection using LinQ? Path 0 0 1 0 1 1 0 1 minus 1 1. Yeah, that's good. Zero zero 1 0. It finds 5. What the? No. What the? I'm confused. Come on, debug. What the? Weird. L2. I should remove the origin point. Yeah, I should remove the origin point from the list. Easy. I do use it in plotting, but I don't want it in the result. So before I do anything, I say plotted points, remove origin, panel origin point. And here I added the origin point. Here. Thumbs up. Let's try again. Much better. Now, which one is failing? With 1 items, but was this many items. 3 more than just this. What? Which one failed? So oh, intersections failed. Distance succeeded. Okay. That's better. My intersections are failing. So this one should have been 1 point. Why is it this many? Yeah, it should be just 1. You won. So given path and oh my god, I intersect with myself. Jesus. Oh, the pain. Intersect yourself. That will be my next curse word. Okay, test pass. Let's run all tests of all the date challenges and see if they pass. All tests pass. So I can proceed to one final test, which is with the input of the assignment. So I take the input of the assignment. Maybe I already have it. I don't, because I would have said so. And I actually, maybe I do have it in day 3. I don't, okay. It's actually in demo. Presentations, input. Yeah, here. Text file. See 3 tangled wires. Jesus Christ. Okay, I'm scared. Demos. Challenge 3. Demo 1. Demo 2. Input C3 / tangled wires. So I say new panel with wire untangler, and I say panel calculate closest distance. Calculate closest tangle distance. Closest tangled wire distance is R tangled closest tangle distance. Okay, so in program we start this one. For now, of course, we do we do this. Let's run. Thank God, file not found. Input / tangle.txt. And what did I write? I forgot to mark copy always. Okay. I'm scared. If I don't get the right answer, I will go to sleep. Oh my god, I'm so happy. So happy. Yes, yes, yes. Awesome. So happy. It turns out that this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach intersections. Choose the intersection where the sum of both wire steps is lowest. What? Choose the intersection where the sum of both wires is lowest. If a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of a specific intersection. The number of steps a wire takes is the total number of grid squares the wire has entered to get to that location, including the intersection being considered. Again, consider the example from above. In the above example, the intersection closest to the central port is reached after 8 plus 5 plus 5 plus 2 equals 20 steps by the first wire and 20 steps by the second wire, for a total of 40 steps. However, the top right intersection is better. The first wire takes only 8 plus 5 plus 15. So basically, shortest path finding, if I understood correctly. The intersection closest to the central port is reached after 8, 5, 5, 2 steps by the first wire and by the second wire, for a total of 40 steps. However, the top right intersection is better. The first wire takes only... I don't get it. In the above example, the intersection closest to the central port is reached after 8 plus 5 plus 5 plus 2 equals 20 steps. 8 plus 5. Oh, this one? In the above example, the intersection closest to the central port What is a central port? Okay. Central port. To do this, calculate the number of steps each wire takes to reach intersection. Oh, that intersection. Choose the intersection where the sum of both wire steps is the lowest. So it doesn't have to be closest, but the distance has to be lowest. Oh, I see. So it's pathfinding. So I know dumb answer, which would be calculate lengths like this. So this and then this and then this and then this and then this, all the way the same with that. So I would take intersections and calculate distance. Okay, that's easy. Let's do it. Easy peasy. Lemon squeezy. So first I need a test that will calculate a distance, like how long is a wire. Wire length tests. Wire length, wire with length input. So we start from the input. I actually feel really tired right now, guys. And I will just design a test which fails, push it, and put it to tomorrow. Because I'm sorry, I'm really tired. What am I doing? What am I doing? What am I doing? I need something similar. Wire with length input. I actually think I'll extract my member data into class data because they, in my opinion, pollute test. Only if it's trivial, it will go as member data. Otherwise, no. And probably as a trivial non-primitive. If it's many of different input, it should go to class data, I think. Unless it's primitive. Okay, anyways. Wire with length input. Public class. We take this, we implement that. We say yes, of course. We say enumerable object. And we say KD. And then we say, I don't need any of you. And then we say that we build wire from literals. So we say yield, return, new object, where we define our distance, our wire literals. So let's come up with something where it would be trivial. So I think the key point here is that wires shouldn't be included in intersection. I mean, when I count intersections, I don't include the origin point, but intersection is a part of a wire. So that bit needs to be done. Anyways, we go 2 bits left, we go 2 bits up. What's the length? It's 4. We go 1 bit left. What's the length? It's 1. Then we say we go I don't know. I think that's enough. So if I run my tests, obviously import, and obviously say that we have path and then distance. And we say we say we say valid wire parsed returns expected distance. So I say that I create a wire. So I create a wire from path. Then I say wire yeah. Then I say wire distance to wire.length get length. Public int get length return 0. Obviously a test will fail. So wire length is wire.length, and I say length should be expected length. Expected distance, it's not length. Actually, it's length. So length, expected length. Done. If I run this, the test should fail. And tomorrow I'll fix it. As we can see, the test fails, and we'll fix it tomorrow. So here I say day 3 part 1 done, day 3 part 2 Test done, work in progress. Awesome. Push. So that will be it for today, guys. Thank you for watching and see you next time. Bye-bye.